Hello everyone, welcome to another session of the SQRSEC Hacking Labs. Today we are looking into lab number 2. In today's session we will see how we can get access to another user's account, and we will try different techniques from broken access control to SQL injection. We will try to find out if there are any leaked session IDs, and we will look into the strength of the session. Before we get started, make sure to also check the previous vlog where I explain a bit more on how to get access to the SQRSEC labs, how to log in, how to submit the flags, and all the information that you need for these labs. So yeah, let's get started. As always, we come to the SQRSEC.com platform, and if you have an account, navigate to your profile and to the products. As long as you are subscribed to the weekly pen test tips and tricks or to the web hacking labs, you should have access to the same things that you see in this vlog. So first I will go to the web hacking labs and navigate to the lab number 2 and scroll a bit down. Here we can see where we can find the lab, the full path. The difficulty of today's lab will be easy, and compared to last time, this time we also have a test account, which is Wally. There are a few notes and objectives. The notes are a few things that you can keep in mind so you don't have to waste time on attacks that don't make sense. For example, all the SQRSEC hacking labs are protected against password brute forcing or password spraying or any password attack, so you can usually skip this type of attack vector. If you find any cross-site scripting, this is usually out of scope. We try to find what is the flag, and usually cross-site scripting, if you find something, might be dedicated to that lab, but in this case it's out of scope. And lastly, the only target in scope for today is hosted on port 443, so you don't have to do any nmap scanning, and you can be sure that everything that you need is on the web interface exposed on this port, so you don't have to try to find other logging portals, other interfaces, and so on. And our objectives for today is to log in as admin and to retrieve the flag. We can see that we already have low privilege user, Wally, and we'll try to see how we can get from Wally to admin, and once we get to admin to get the flag. And the flag in today's lab is in a format as UUID, so it's quite hard to guess and to brute force it unless you obtain it as it is intended. So let's go to the Hacking Labs platform, which is labs.squaresec.com. If you are subscribed to either of the products, you should have received your credentials on email. Make sure to also check the spam folder in case you didn't get them. So navigate to the Labs platform and log in with your account. I will do that as well. SQRSEC Labs. And we should be redirected to the challenges page. And as I mentioned before, today's lab is easy, and it's lab number 2. And here you can see exactly the same details that I just presented. Important note, you have to use your account that you used for this platform to also access the challenge, which is hosted over here. And once you get the flag, you submit it and get the points, which are 15 points for today's lab. So let's go to the lab 02, squaresec.com. You are asked for credentials, and these are the credentials for the platform itself. Once you log in, you should have access to the challenge. So this is step 0. This is where the challenge starts. And let's go back to see the test account that we have, which is Wally. So I'll go first and try these credentials just to make sure everything works as intended. Wally, and login. So it seems that the credentials work, and we are logged into the portal. We can see a welcome message, welcome Wally, and we have to log in as admin to get the flag. Perfect. Let's turn on the proxy and then look a bit more on the lab and what is going on in the background, what type of requests and response do we get from the server. So I'll log out, turn on the proxy, and do the same process again. Let's close these tabs first. Turn on the proxy, settings, proxy, and manual proxy to localhost 8080, which is our burp instance. Okay, close this. Let's refresh and go to burp, and we can see let's delete this one, yes, and let's add this to scope, and yes, and let's see only in scope items. Perfect. Just a quick note, I explained this in the previous blog, but I will explain it again in case people have missed it. There is an authorization header that you might see in the challenges. This authorization header has nothing to do with the challenge itself. It's the authorization header for accessing the SQRSEC Labs challenges, which are protected from public access from the internet. So this is just to make sure that you have an account on the SQRSEC Labs and you are logged in to the Labs platform when you access the challenges. So idea is that we can ignore this in most of our labs. Okay, so we have a get request to index.php. Let's send this to repeater and look to see if there is any information, and then I will also send again the credentials to see how that looks like. So Wally, and login, and go back to burp, and now we have a post request as expected, and we can see username and password, very simple form, very basic authentication. So I'll send also this to repeater, and I will rename these tabs just to make them easier to remember. This is the index. They are both the index. Oops, I closed it. They are both index, but I will rename the second one as login. Login submit. Let's go like that. So let's send this again, and we see that we get a 302 redirect, and we get a set cookie response header, which tells us that we get what looks like a JWT token to set in our session. And if we follow the redirect, we are redirected to home.php. And if we render this, we see that it appears that we are not logged in. Let's see why that happens. Logged in. Home. Let's do this again. Refresh here. This is interesting. I don't know why I don't see the home page, home.php, in our proxy. So we have a cookie, and it seems that our session was not set for some reason. Let's do this again. Let's go back to the submit. Let's do this, and maybe if we copy this manually, follow redirect, and get the same error. What about if we put it manually? Yeah, if we put it manually, it seems that it works. Interesting that when I follow the redirect, it's not picking up the session from there. I don't know exactly what is happening, but let's go back to home, and if we put the session that it was set manually, we see that we are actually logged in. And I will save also this one as home.php, and I will keep this one as the submit one. So now we have already 3 different requests. We have a get to the index, which gives us the login. We have the submit of the form, which sends the credentials, and then we have the form, the home, which takes the credentials, checks if it's valid credentials, valid session, and it tells us that we are logged in as Wally, but we have to log in as admin. Okay, if we go back to the lab, or if we remember what the lab was about, let's do that. It was on labs, SQRSEC, challenges. And so the objective was to log in as admin and retrieve the flag, and we see that we have a Wally account. What I want to do now is explain a bit what are the attack vectors, like how we could possibly move from a low privilege account to a more to an account that has more permissions, like admin. So what I want to do right now is pick a few attacks that I would usually perform when I need to do this kind of scenario, and then see which one of them makes sense to try in our case, which one we can discard because they are not relevant. And for those that are relevant, we will try to actually perform them and see if we get anything out of them. So to get from a low privilege account to an admin, there are a few things that come into my mind. So I'll make a new node in cherry tree. Let's say attack vectors, something like this. Okay. So one of them would be, let's say, password spraying and password brute forcing. But since we already saw in the lab notes and objectives that password spraying and password brute forcing is out of scope, we are just going to make a note of them, but we are not going to try them since we know it doesn't make sense in current. But if you are doing like an actual pen test, or you are doing bug bounty, it is worth trying to see if there is any rate limitation or something that may allow you to actually perform such an attack. Even though in most cases this wouldn't work, it's still a finding if there is no rate limiting. Another thing that would be worth trying is broken access control, let's say broken access control by accessing directly the URL or the path. So let's say we are looking for a flag, or we are looking for more information in the admin portal, and we have only a regular user account. What you want to try in that case is to do some kind of file or brute force enumeration, and to look for paths such as admin or admin/portal.php and all kind of paths like this. And we will try to do this using a common list, and to see if we actually can access something from the admin portal using our low privileged account. So we will keep this in scope. I will make a note that this is out of scope, so everyone remembers this, and we will put this in scope, and I'll make a, let's say, file folder enumeration, and you can do this either with intruder or FF or GoBuster, so you don't have to have like a paid pro license for intruder for a burp suite to do this. You can also use some CLI tools, maybe Ferox Buster as well, and many other tools. So so that's pretty much it on what we can try from this one. Something else, since there is a form where we do the login and we provide username and password, we can of course try for SQL injection. And if there is a SQL injection attack, we can either log in as another user, and in our case would be admin, or we can maybe or dump the database tables, find the password hashes, and then using the rainbow list or leaked passwords on the internet, we can try to see if we can actually get access to another user. So we will keep this in scope, and we will try to use a SQL map for this kind of attack. What else? We can also try to see if there are any leaked session tokens cached on the internet. For example, we can use the Wayback Machine, and based on how the application has been configured, sometimes it is possible that let's say if there is a login.php and then we have a session equal 1234, and this one gets cached on Wayback Machine, we can replay that one and then access. So we will use Wayback, I think it's called Wayback URLs or something like that. We will have to see. I think it's a CLI tool, and we will try also this attack to see if we find anything cached on the Wayback Machine, and if there is anything related with the login or the session, we can try to replay that one. And then lastly, we can look for weak session tokens. Since we already have an account, we have the Wally account, check how the low priv, so Wally session looks like. Can we assume how it was generated, and then if we can do that, let's forge our own session, right? So maybe sometimes the session is just an MD5 of the password or of the user itself, would be more of the username, and then if we somehow deduct that has been the case and that's how the application generates the session, we can do also, let's say, MD5 of admin. We get that session, we set it in our own browser, refresh, and then get logged in, right? And then since we already have seen that the session is JWT, it's worth to try some JWT attacks. There is this tool called the JWT tool that runs all kinds of attack by providing you provide the JWT token, and it will try to see if it's strong enough, if the signature is proper, if it uses symmetric or asymmetric encryption, if you can try to brute force the secret, and so on and so forth. So let's mark this as 1, 2, 3, 4 just to be easier to reference. And now that we have, let's get this one like this. Now that we have some attack vectors, we'll start to try them one by one, see what we get out of it, and see if we can actually abuse any of them, if there is any vulnerability, and if we can actually pivot from Wally to the admin account. So I'll create a new node under this one. Let's say broken access control. And as I said, for the broken access control, we will try to do some file folder enumeration, and maybe we should pick a list that is more relevant for admin portals or something like that. So let's see what we have in sec list, if there's something nice there. Otherwise, we will move on with the SQL injection. So we already have a session active. I'll send this one to intruder. Let's try to make sure. Yeah, we are still logged in. I send this to intruder, and instead of home.php, I'll add the injection point here, and let's load something. Let's see what we can find here. Let's say, so in seklist master, let's go for discovery and web content, and I'm looking for something that is targeting, for example, admin interfaces or something like that. Not sure if there is something specifically for that, but otherwise we can use the raft list and see if we get something out of it. Maybe in the URLs, see what's here. Drupal. Now these are very specific to this kind of technology. We don't know for sure if we have those. I don't think we have them. We can do a quick check, but I think we would have known if that was the case. Let's go to the API actions, API endpoints. Maybe it's something worth looking. Let's see how it looks like. I'm looking for something maybe with PHP, but we can also add our own extension to it. So this one has API. We don't have actually an API. We don't see to have any API here. The repeater, we have directly the pages, but it's still worth trying, so I'll keep that. But what I want to do is also add, actually remove this one and only fuzz this part, the home itself, and let's say like this, because the slash is already included in those paths. So what is going to happen is we're going to look for API slash videos, and then we are appending PHP, because we saw from our recon so far that we have a PHP extension here, and we have a PHP extension here, and we have a PHP extension here. So we can assume that if there are more pages or endpoints that are there, having a PHP extension might be very likely. Back to intruder. Let's see how many. There are only 200 paths here, so maybe pick one more list. I'm going for the quick hits one. We have 2000. Let's see if we can find one more, or we stop for this one for the moment. Maybe common. Let's go for common. And common has some nice paths, especially if we append the PHP to it. We might be able to find some good ones. But now we have around 7,000. Let's run this attack and let's see if something comes back. So I had to pause because it was actually encoding the first slash, and we can see also the second slash. So the requests that we were sending were not properly formatted. So I'll stop this attack and I'll discard and make sure I disable the URL encoding of special characters. Or we can simply just remove the slash encoding from here and keep the URL encoding. Actually, let's disable it and start again. So the attack finished. The intruder list that we have used has finished doing its job. And let's see if we have any different status code. We have the 200 OK, but this is for the baseline for home.php, and we know that already that is available. So nothing new here. And if we sort by different status code, let's see if something else comes up. We have 404, and then if we scroll all the way down, any missing requests, any missing response. Let's see if we have anything here. 404. We have a 200 here. Let's scroll a bit up. What's going on? So we have the 200, but again, that's the baseline. And then we have some errors from the server that it couldn't return the response. So one of the problems with servers that don't have enough resources, it may be that the intruder attack or the tool that you are using for enumeration, it is too aggressive or is using way too many threads when it's doing the enumeration. So this may lead to either crashing the server or not being able to return responses to all the requests that we send. So what I want to do in this case is I will repeat the attack, but I will send way less requests at the same time. So we will limit the number of threads that is sending, and we will let it run in the background while we will look for the next attack vector in our list. So I'll close this one because we don't have anything else besides the 200 for the home. So we will repeat this attack, and we can also add a few more lists just to have it run in the background while we test for different things. So let's go for Raft, the Raft small one, if we can find it. Raft medium, and either directories or files. Let's go for, let's see what files has. It seems like we have PHP and HTML, but since we already have added PHP extensions, I'm going to remove them all and remove also the PHP extension from here. So we keep the extension that comes with the list. So we are going to load again the Raft and the files one. Raft medium files. Let's go for this one. And we can see that it already has PHP extensions, txt, and I think HTML as well. So I'm going to remove this from here and PHP, and we also have to add the forward slash before, because this list doesn't have it included with it. And this one has way many more payloads, so it will run for a longer time in the background. And as I said, in the resource pool, we are going to create a new resource pool that will adapt for this type of server. So let's say slower requests. You can name it however you want. And in the maximum concurrent requests, you can also say, let's say 5. And we can add a delay if we feel like that's needed. And what I want to do is automatically detect if the server sends back 402.29 error code. This is usually something that we get when we send way too many requests. So we can also enable the automatic throttling. And also for 503. I'm going back to the payloads. This looks nice, and start again the attack. So this resource pool invalid, delayed. I think I forgot to set that one in here. Let's say 10 milliseconds between. Now we have this one running. We have a 302 redirect, but we already know about index.php. The previous list didn't have an index.php, it only had home.php. So maybe this is a better list. Let's have it run in the background and try to see what else we have on our list for attack vectors. So if we go for the broken access control, let's say currently running using Raft medium files. So we'll come back to this later. And the next one was related to SQL injection. So if we go back to the repeater where we had the post request and login submit, let's try to do this again. You can see that we get a session set for us. I forgot to look more into the index.php itself to see if there is any interesting information in the page. We have some fonts, nothing interesting. We have the fav icon, again, nothing interesting. Style sheet, CSS, the background image, and we have a very basic form that we see that sends a post request to index.php, which I have already seen. It takes the username and the password. There are no hidden fields or anything else. I don't see any comments, something like that. If we look in the, so this was the get request. We look in the post request, we only get 302. Let's try to do some wrong credentials to see what we get back. If we look in the, so it says invalid username and password, and in the raw request looks pretty much the same, except that now we also have a div that has a class error, which displays what was the problem with our login. I don't see any other differences. And if we go to home, let's say the raw rendering, same things, CSS, and if we scroll down, we just have the welcome message for our current user, and it says that we have to log in as admin to get the flag. Again, I don't see anything interesting in the source of the pages. We have a button for logout. Let's try that action, because that one we haven't tried. We go back to the browser. Let's see what happens when we do the logout. And if we go back here, we have a request to home.php, and we have a parameter logout equal 1. So this looks interesting. It's good to have it saved, because this is the first parameter that we have identified besides the username and the password, but this one is in the URL. So for the SQL injection, we currently have 3 inputs that we can try to see if there is any vulnerabilities inside there. There is the username itself, there is the password, and there is the, where was it, the logout parameter. So let's send this to, where should we send it? Let's actually try SQL map. It's better than trying intruder itself, because we already have intruder running in the background with the Raft list. So I will take the request from here and go to Kali to start with the fuzzing of this one. If we open Kali, in, let's say SQL map h, and I think the syntax is quite simple. It's way simpler for when you try to fuzz a parameter. So this looks very similar with what we have, except that in our case there is a logout equal 1. In this case is an ID equal 1. So what we have to do is pass the -u parameter to test the target. So I'm going to say SQL map -u, and let's take the URL from burp. which was this one. And actually, let's do it like this, it's much easier. Let's paste this. And one thing to keep in mind is you really want to put HTTPS. There were some cases when I only used the top level domain and I didn't specify protocol to be used. So SQL map assumed that it was HTTP, and because the application was only supporting HTTPS, I got a lot of errors that it couldn't find any vulnerabilities, even though the application was vulnerable. SQL map couldn't actually reach the application, and the error was not very useful to find out what the problem was. So make sure to include HTTPS, and let's take the path from here, add it here, and delete this part. And let's run this, see what happens. And we get a critical error. It says that we are not authorized and try to provide the right HTTP authentication. The reason why this is happening is, as I mentioned before, the lab itself is also protected with basic HTTP authorization, as we see here. And this may be also the case if you pen test some kind of internal application sometimes, or you already have credentials for an application, but you don't pass it by default to SQL map when you only provide the URL. So what we want to do in this case is let's say SQL map, and let's look for help, and maybe grab for header, and we want to say case insensitive. So it says that we can provide a cookie, and we can also provide a random agent, but what I want in my case is a very custom header. So cookie will not work because it's the parameter that we want to pass the HTTP auth is in the authorization header, it's not in the cookie. So we have to find a way to pass also this authorization, but also the cookie, which contains the session. So I'll start with the session since we already have a flag there. Let's go here and run like this. And I'm going to say dash cookie, and I guess this should be the value encapsulated in double quotes. So cookie equal double quotes and paste clipboard. So now when SQL map will perform SQL injection attack, it will send the request to also include the cookie. But the second thing that we wanted, as I mentioned, we want SQL map to also include this authorization basic. Otherwise, it's not possible to reach the lab itself and test it. So let's try to see SQL map, custom HTTP request header, see what we get. Adding header options to SQL map. So it seems that there is a headers, and it's time to see. So apparently there is a dash headers. I don't know why we didn't see it when I asked SQL map for help. Maybe it has a more advanced help, something like this. So there is a advanced help which has double H. Let's look at that and make grep again for header. Okay, so now we get more hits, and we get one for headers, which adds extra headers, and we can add pretty much anything that we want as part of this. So what we can do now is go back to the initial command that included the cookie. And also add our custom headers to include the HTTP authentication. So I'll copy this and also include it. And let's see if our SQL map works better now. Since I've got a 302 redirect, so previously we got a critical and not authorized. It was asking us to provide HTTP authentication, and this time we managed to have SQL map reach the actual application, and we got a 302. And usually when SQL map asks you something, it has also suggested what you should consider to do, and in this case it says yes. So yeah, let's go with the yes. See if it finds anything. And it finished. Since that we got a critical error, not sure why it is a critical, but it appears that all tested parameters, which in our case was, let's scroll up to see, the logout, which was the one, was not injectable, and one of the things that it suggested us is to increase the level of attack and the risk, or we can use different tampering methods. What I'm going to do for the moment, I'm going to save this output and continue with different attacks, because we don't want to get into a rabbit hole to continue to fuzz this endpoint if there is nothing there. But if at some point we run out of all the things that we have tried, we have something to come back to and increase the level risk, increase the level, increase the risk, and maybe play a bit with the temper to see if we can find more things. So let's save this just to have it logged. And going to attack vectors, we have broken access control. Let's say this is running, and then I'm going to add another subnode. Let's say SQL injection, and under SQL injection, I'm going to say logout. Let's say logout because this was the endpoint. I'm going to save this here, and I'm going to also say to do increase level risk, and rename this to later, so we know to come back at some point if nothing else comes out of the other attacks. The other HTTP request was the one that was sending the credentials itself, so the username and the password, and the logout, let's call it logout. The logout had the injectable parameter in the URL, and that was easy to fuzz with SQL map because all we had to do was to provide the URL itself, as we see here, and SQL map knew how to pick it up because it was in the parameter. But for the second one, the login, the parameters are in the post body. So when we try to attack those parameters, we have to specifically instruct SQL map to look inside the body where the parameters are, which ones we want them to be checked. And also we have to provide the whole HTTP request to SQL map, not just the URL. So I'm going to save this into a file on Kali. Let's go here, and let's say maybe login.php. Save this into the file. Here we already have the authorization, and we don't have the session, but that one is not needed since this is the post request to log in. So when you log in, you don't have an active session on the website. I'm going to save this. Let's see how it looks like. So it looks good. It's properly formatted. And now we are going to check how we can use SQL map on a post request. So let's say SQL map post request file, something like that. So let's see what it says over here. So we have SQL map, and then we have a parameter -r where it passes the request itself, and then we have -p, which stands for the parameters, and it specifies which of the parameters from the request we want to fuzz. So let's go back to Kali and do the same thing. SQL map, then we have -r, which is the request, right? -r, the request that we just saved, which is login.php, and then we have -p, and in the -p it is the parameter that is over here. So in our case the parameters are username, take this one, and comma, password. Let's say if it works with comma, otherwise we can do it 2 times, once with username and once with the password. So I'm going to run this and see what we get. Seems like we get a critical error and we are unable to retrieve the page content. Let's see what the problem is. Providing parameters username, comma, password are not inside the cookie. I don't know why it's looking inside the cookie. And then testing connection to the target, unable to retrieve the page content. HTTP error, permanent redirect. So let's see why we have a permanent redirect. If we repeat the same request from here, we get a 200, okay. So maybe it has something to do with the parameters. Let's test only one at a time, see what we get. Okay, we get again a critical error, and then we get 308. And this was one of the things that I mentioned before, is if you look in the login, you only have the top level domain, but there is no instruction anywhere that SQL map should use SQL map should use HTTPS instead of HTTP. So this was one of the problems that I usually encounter with this one. And I think let's go a bit back to SQRSEC labs. I think there is a go to products. There is a pen test tip and trick for this one specifically. Say SQL map. We have a command generator. Do we have anything else? When SQL map fails, 3 tips. What do we have here? See a post. Yeah, this is something that we have. We fuzz for command list. Why? Enforce SSL. So this is one of the problems that I usually encounter. So instead of using SQL map -r and request, we have also to provide -- force SSL, and this will instruct Kali that it should use HTTPS instead of HTTP. And here we can see it's exactly the same problem that we are having. It's a critical and the target can be behind some kind of WAF. We don't get exactly this problem, but we get the same problem. So let's try to see what happens when we provide the force SSL. Let's play this and let's do basically port force SSL. So now we see that we don't get that critical error anymore, and SQL map has managed to reach the target and is performing the SQL injection on the username parameter. So let's see if we get anything out of it. So we get a message saying that the post parameter username appears to be Oracle and it's time-based injectable. That sounds promising. Let's go with TS, yes, and see what we get. And again. So it finished. Initially it thought it appears to be injectable, but in the end it said that it's not injectable. So it might have been some false positive at this one. It's something more than we got compared with the logout parameter, but again, we didn't manage to perform a proper SQL injection and to extract the parameters. Let's try to play a bit with the level and the risk to see if we get a bit more out of it. And then we can also try to do SQL injection on the password, and if nothing comes out of either of them, we can move with the next attack. So I'm going to say dash level. What are the levels? Let's see. SQL map each edge, and then we grab for level. So level is between 1 and 5 and default is 1. So let's increase this to 3 or 5, something like that. Level. Let's see also the risk before we run it. The risk is between 1 and 3. So let's say level 5 and risk 3. Let's see what that brings us. So SQL map finished, and we can see that it didn't find anything, and it took us more than 1 hour to run this extensive check. Unfortunately, this is how it is in many cases. While you do a pen test or a bug bounty, you have to try many things, and many things will fail. You never have a guarantee that the test that you run will actually succeed or find something. But let's save at least the command that we have run and make a note in our cherry tree that we have already tried this and it didn't find anything. And just before we move forward, we will run just a basic check on the password field as well, because it only checked the username one. So I'm going to change this one to password and do just a basic check without all the level 5 and risk 3. So while we have this running in the background, I'll make a note that we have checked the username field and nothing found. And I'm going to add also the command that we run. And then let's make also a note for the fact that we are checking the password. And and let's see if we get something out of it, or again we don't find anything. So it's recommending us to do only the basic union tests. We will go with the recommendation. So yes. And again, we can see that we didn't find anything. For the moment, we will skip the extensive check on the password field as well, because we saw how long it takes to check with all the checks. So I'll just make a note of the fact that it didn't find anything. Let's put this like not found, and I'm going to paste also the output so we have it in case we need it later. And if nothing else comes, we can always return and do an extensive check on the password as well. But for the moment, I think we kind of tested enough. One last thing, let's go back to our burp. Here we have an index page, and we have the home page, and we have again the home. So we have two pages and two different methods, one with a different parameter. We can use a tool to discover additional parameters for this, because what we found so far was just one logout, but maybe there are other parameters that maybe are not included in any of the pages, but they are still available for us to send to the backend server. So we can use a tool like Arjun. Let's see if Kali has it installed by default, otherwise we will have to install it ourselves. So like this, we want to install it. Yeah, let's see if we can do that. Let's upgrade. And as I said, Arjun is a tool that we provided with a list of URLs, and it will try to find additional parameters that we may be able to fuzz, or some parameters that we are not aware that they exist. Let's see if we have it now. So Arjun dash help, and we have a target URL, and I think we can also provide a target list. Let's see if we have a word list, and the word list is no, the word list is the word list of the parameter. This is not what we want. What we want is -ot, and this is the text file with all the paths of our tool. And another thing that we may need is to add the custom header, where we will provide the HTTP authentication. So let's make sure that our session is still valid. So we can see that it's still valid. I'm going to take the basic auth parameter and make sure to include it in Arjun. So Arjun dash headers, and it should be something like this. And then we will have -ot, and let's say paths.txt. And I'm not going to execute it right now because I don't have yet a paths.txt, so we have to create that paths.txt. And in paths.txt we want to put index. Let's add this one. It's only two paths, so we can do this manually. If there were many, we could have exported the list from Verb or something similar, but since it's only two URLs, it's faster to do it this way. So index, and then we have the home. Index again, and home. And we save this, and now we run Arjun to see if it can find additional parameters on those two paths, and if it does, then we can run SQL map also on the new parameters that it found. No target specified. What is the problem? Has OT provided? Path to text. Oh, this is the output file. Sorry, I just missed this. So we have -u target URL. Word list? No. Let's see on the GitHub page what does it say. Maybe it has some examples. Import targets. Let's see this one. Specify HTTP method. Import targets. -i. Importing targets from Burp Suite. We could do this. Export results. Specify injection point. Delay. Request timeout. Rate limit. Disable redirects. What's the -i? Simple text or raw files. Okay, maybe it's the -i parameter. -i import file, import target URL. So this is actually what we wanted, not the OT. So now it's going to scan for additional parameters. We see on the index, we see that we found 2 parameters, the password and the username in the body. And we can see that it also found the logout parameter in the home-php. So Arjun also found exactly what we found, username, password, and logout. So unfortunately, there are no more other parameters, at least in the paths that we are aware of, that we can fuzz or that we can try to do SQL injection on. So let's move forward to see what other attack vectors we've been looking on. So for the moment, we pause the SQL injection. We have the intruder running in the background. Initially, we didn't find anything, so we still ready to run to see if anything comes up in the end. And the third thing that we may want to look for is leaked session tokens. And one place that you may want to take a look is the Wayback Machine. So we have a CLI tool actually in Kali. I think it's installed by default, which is Wayback URLs. And Wayback URLs is calling the API of Wayback Machine, and you provide the URL for it. So in our case, we can provide the URL towards our lab. And if this lab at any point has any type of session tokens in its URL and Wayback Machine has cached that information, we may be able to query it, find again those tokens, and then try to replay the same token and see if we can get access to another user's account through that token. So I'm going to start with HTTPS, see if we get anything. So nothing came back, see just an empty reply. We can also try HTTP just in case. Again, nothing came back, and maybe the top level domain. Again, nothing came back. So we can save this output and make a note again in cherry tree to make sure that if at some point we want to remember what kind of tests did we run, or if Wayback Machine came with anything, we can refer back to it and see that we didn't get anything out of it. So I'm going to make another subnode, and let's say Wayback Machine. Actually, let's say nothing found, just to be easier to see directly from the name of the node. So here we have the output for the Wayback Machine. So we are still looking into this, running in the background. For the moment, we have paused the SQL injection because we didn't find anything in the 3 parameters that we tried. For the leaked session, we checked the Wayback Machine and we didn't find anything. Another thing that we may want to look for are any kind of log files. We didn't discover yet any log files where this may have been cached, and maybe try to trigger an error in the application, and then in this type of errors you may be able to leak some kind of information, among which maybe you find a token if you are lucky. So maybe let's try to trigger some kind of errors and to fuzz some of the parameters to see if we can to some extent make the application throw some errors back to us. So if let's do this manually. We can go to repeater. We have the home, but I would try in the username and password, sending this to intruder. I'm going to pause the other one while we are doing this, so because the server may not be able to take so many requests. And then let's put in the parameters in the username and in the password, and we can go for a full fuzz, at least in the beginning, to see if we get anything out of it. And we don't need to actually, let's skip the URL encoding and let's start this. So the fuzzing is done now, and we can see in the length, we can sort either by the length of the responses or by the status code. All status codes are 200 okay, we don't get any 500 internal server error. Usually those are the status codes that you may want to look for in an attempt to leak some information through errors. But we can see that the application is handling pretty well invalid parameters and invalid values. So regardless of what we try to throw in those username and password, the application had proper error handling on the backend, and it never told us that there has been any kind of error or leaking the stack trace. We can run it one more time without doing the URL encoding, just to be sure. So just do that. I'm going to disable it and start again. So again, we finished the fuzzing. This time we didn't URL encode the payloads, so we can see that they are exactly as we have them in the list. And if we sort again the results either by the status code, we see that all status codes are 200 okay, so we didn't get any 500 internal server error or another status code out of our fuzzing. And in the length, let's try to see, the length is always the same. And if we check to see what is the response, and let's render it, we can see that the login form is just informing us that the invalid username and password have been provided, but no other information outside of that. So unfortunately, our fuzzing didn't reveal more information that we already knew. So I'm going to close this and again make a note about the fact that we run some fuzzing to try to do some leakage of information to this endpoint, but we didn't get anything. So I'm going to, as part of the attack vectors, add a subnote fuzzing / session leakage, let's say. Nothing found. But then again, there are other places that you may want to look into or you may want to try. One could be the cookies, since those are the ones that are being processed by the application. The session cookie, we don't have it here, but we can take it, for example, from the repeater. In the logout, you can see that there is a session over here. So actually, let's send this just to make sure that nothing is hidden here, and we can also fuzz this, since we know that the application has to parse this information, and if we can manage to throw an error out of this, maybe we can find more information. Another thing that maybe you want to try is the user agent. Depending on how the logs are being set up, maybe there is some parsing being done on this. So there are different headers that maybe you want to try, and even try to discover new headers and then inject into those. So you can see that you can perform more and more attacks as time progresses, but in the beginning you want to try the basic things on all the attack vectors, and if you don't find anything, go to the next level and to the next level, and then dive deeper and deeper into it. So let's do one more check for the session, and then if we don't find anything, we make a note, and then we will come back later if nothing comes from the other attack vector. Again, we're going to load the fuzzing full list, and let's do it with the URL encoding first and then without. So we see that all the status codes are 302 redirect, and the redirect is telling us to, let's say, is telling us that the location for the browser should redirect us to index.php, and then all of them are setting the cookie to the session cookie to deleted, which means that is invalidating our session cookie properly. Let's look into the length. Maybe there are some that stands out, and we can see no matter how we sort it, all responses have the same length, and all responses have a 302 status code. So at this point, we can be quite sure, at least for the list that we have used right now, that there is no errors being thrown by us fuzzing the session cookie. So I'm going to close this and make a note of it, and then we will move through the last attack vector that we mentioned in the beginning. I'm going to discard this, and then going to cherry tree, fuzzing session, and say nothing found. So the last attack vector that we had was actually it was this one, and then we also have the session, but they are somehow related because we have weak session tokens. If we look at the session that is being generated, it's a JWT, so we can look at those two together at the same time. Let's go back to Burp and see how the session, the JWT is structured as. In the repeater, we have the token over here. Let's go to the JSON Web Token extensions, and if you have like a free version of Burp or you don't have this extension installed, you can always go to jwt.io and you can decode the session over there. We get a weird message. It says that the signature is invalid, so we will have to dive a bit deeper into like why this is happening. But at the moment we can see that we have the header of the JWT token, we have the body, and then we have the secret. And it says that the secret is the signature verification failed. So maybe we can abuse this to some way. The JWT token itself is quite simple. We can see that the algorithm is HS256, and this is a symmetric algorithm. So it means that the same it has used one secret to sign and to decode the signature to verify it. And this type of algorithm is prone to brute forcing and cracking attacks. So if we have a list of known secrets, we can get one of these JWT tokens, take it offline, and then using, for example, Hashcat, we can try to see if any common secrets have been used to sign this token. And if we find which secret has been used to sign it, then we can forge our own JWT token and then create one that maybe gives us additional access, because we see in the body of the JWT token that it contains one field, which is the username and Wally. So the assumption would be that if we can create a JWT token where the username is admin, and then we can sign it ourselves and then provide it to the application, maybe the application will log us in using that user. But let's look a bit through what SQRSEC tips and tricks, what tips do they have about JWT tokens, and if we have anything there that can help us to move forward with the JWT. So I'm going to search for JWT, and let's see, we have 3 different matches, and they are all in the cryptographic failures section. The first one is about exfiltrating JWT tokens from source page. Unfortunately, as we can see in our application, the JWT is not stored in the source code, it's stored in our session cookie. So we may not be able to abuse this one. And if we continue to look, we have one for automating JWT pentest, and we have one about cracking JWT tokens, the one that I just previously mentioned. So if we look into the automating JWT pentest and scroll a bit down, we can see that we can perform a lot of security checks on JWTs using one popular tool called JWT tool. I'm not sure if this one is installed by default on Kali. Let's check. And if it's not, we will have to clone it from GitHub and set it up. So JWT tool, command not found. Let's go to GitHub. We have a reference here. Yes, over here. So this is the tool, and what we have to do for installation, manual installation, we have to git clone this one and then do a Python 3 pip install requirements. So let's do this and see if we manage to set it up. So I'm going to do git clone. Okay, and now we have to install the prerequisites. So yes, actually we have to get inside the directory. And can we just run it like Python 3 JWT tool apply? So this yeah, it seems that we can call the tool directly, and there were no JWT token provided. So let's provide the JWT token, which is this one. We go to Python 3 and help. Let's see how we can provide it. So we have the target URL. If we go to here to SQRSEC tips and tricks, we have Python 3, and then we have the tool, then we have the endpoint. We can provide custom headers with the request request header, and then we can put the token there. For us, it should be inside the cookies, not in the authorization, but we also need the authorization for the labs. And then we say -m pb, and this is probably all the checks that it does. Let's see how it looks like when we run it, and then we will try ourselves on our own application. So what we have here, if I can close this, you can see that it checks for the timestamps, it checks for the when does it expire, if it is still valid, and then it's sending the token that it found, and does some kind of pre-scanning, and then we have a JWT attack playbook that is being run. So those are a lot of, we can see that there are a lot of checks for broken signature, for claims, trying to exploit blank passwords, null signature, the non-algorithm in all different types of uppercase and lowercase. So we have this one running. It does a lot of checks on HMAC signatures, and it's finished. Okay, so let's try the same with the token and the target application that we have and see where we get from there. The command, let's copy that one, Python 3, and replace with our own values. So request header. Let's see if the JWT that we have is still valid. So we can send a request to the home, and we say that the session has expired. So we have to log in again and get another JWT token for that. The password was Wally. And here we have a new token. Let's use this one. Let's check it on the home to see if it's still valid. If it's valid. Yes, and this time the application tells us that we are logged in as Wally. So let's put that, let's take this part with the cookie. And how do I provide multiple, let's see if this one works, multiple parameters, multiple request headers. And then we have this, and we need the endpoint. And for the endpoint, we will use an endpoint that requires authentication. So in our case is the home endpoint. So let's copy this. And home.php. We get an error. Python 3 cannot open file projects. JWT tool, yes, because we wrote the wrong name of the file is jwt.py. And now we get another error saying we have to check the proxy. If the proxy is not needed, disable it. Since that we have an error trying to access this, so let's first try without the cookie and just the authorization. See what to see if this one works, and if we can reach the application. So it says it didn't find a valid JWT. Yes, because we have removed it. So let's see if there is a cookies flag. Python 3 -JWT tool -py help, and maybe grab for cookie. So we have a RC flag, which stands for cookies, and the request cookies to send. So we can include the cookies using the -- cookies flag instead of putting them in the headers as we did it before. So -- cookies. And let's copy this session. Now it should be able to detect that the JWT is inside the cookies parameters. And let's send this. And what we get another error. Let's see what's the problem. It decoded our JWT, so that's good. It means that it identified the JWT that we provided correctly. And sending the token, check that the proxy is up and is not set to tamper with the request. And again, we get an error related with the connection pool. This is quite a bit tricky to debug. So what I'm going to do is I'm going to proxy the requests that are being sent by JWT tool through burp and see why does it fail and what can we do about it. So let's look for the proxy flag. Grab -i proxy. So we have a -np for no proxy, but how do we set an actual proxy if it has that option? If it doesn't have, then we might have to find a different solution. So there is a JWT config ini. Maybe we can find the proxy there. What I can see is only the option to not use a proxy, but how exactly do we use one? Private key. Let's try to find this JWT conf.ini and see what's inside it. Maybe say locate. So it's over here. Say nano. And actually we have a proxy. To disable the proxy option, set this value to false. So it appears as if for Docker install, okay, we don't use Docker, but it appears as if it has been already set up to use a proxy. So what we want to do in this case is just to change the, either we disable it or we change to our own host. Let's first disable it to see if it works, if that was the reason for failing, and if that was not, we can change this to our host IP address and then proxy all the traffic through burp. So I'm going to save this and run the tool again and see what we get. So now we see that it worked. We don't get blocked with the proxy thing, and it's sending the token, and it's scanning modules and some checks. Let's see, pre-scan, we got a 200, okay. No token response, we got 200 and a different number of bytes. So there was a difference when we provided the token and when we didn't. And then we get an error message saying valid and missing token requests return the same status code. Okay, it returns the same status code, but you can see that the lengths are different. You should probably specify something from the page that identifies that the user is logged in. For example, welcome back, tcarp. Okay, and we have to use the -cv message. So this is how JWT tool will recognize whether you are logged in or not to the application. So in our case, it's quite easy. We go to burp, you can see that we get a message which says welcome Wally. So we're going to use this message as a check for JWT tool to detect if we are logged in or not. Welcome Wally. I'm going to copy this. Let's say no, and let's configure it again. -cv, and we put, oops, cv, and we put this message. So now every time JWT tool runs, it looks in the body of the response that it receives from the server, and if it sees the message welcome Wally, it knows that the session is active. Otherwise, it will know that something is different. So let's run this and see what happens. Get another message saying the canary value welcome Wally was not found in the base request. That's weird. Check that this token is valid and you are still logged in. Okay, let's see why we get that. Maybe the token actually expired. No, we actually have the message here. That's strange. As we can see it here. Did we provided the correct message? Welcome Wally. It looks like https home.php. Is this the right page? Home.php, and this is the canary that we look for. So this is strange. Let's try again to see. So it says found welcome in the response, and then it says that the canary was not found. So this is quite this is quite weird, because initially it says that it was found, and then the canary was not found in the base request. But let's continue anyway, see what happens. So we get a few warnings, let's call them like this. It says that the key was not found in the dictionary. The key was probably to test HS256 tokens. I'm not sure exactly to what key does it refer to. And then another one is related with external service interaction. This is if we have some kind of SSRF inside it, and you may want to see if it interacts with another service. And it didn't find much. We can see it run a few attacks. It tried to do the blank password. It tried the non-algorithm in different ways, spoofing, JWKS, injecting JWKS. We didn't get anything out of it, but what we get are some suggestions that we can run a dictionary attacks, and this is the other attack that has been also suggested in the cracking JWT tokens. So let's look at this, what it is about and what we can do about it. We can brute force and crack JWT tokens offline using hashcat, which is exactly what JWT tool is telling us, using hashcat. And how do we do that? If the token is signed using a weak or default value and a symmetric encryption algorithm such as HS256, which is probably the one that we are using, let's say algorithm HS256, It is possible to recover the secret using tools such as John the Ripper or hashcat mode 16,500. So what we have to do is log into the application and extract the JWT token. We have already done this. Find the word list or common passwords or secret, or use the attached one. This is probably the same one that is being in the sec list. Let's see if it's the same one. Sec list JWT secrets. JWT secrets. No, not this one. List. So it starts like this. Let's see if it's the same list. Otherwise, we can try them both. It looks like the same list. It's quite large. So let's download the list suggested in the cracking JWT tokens article, and let's see what we have to do. We have to use hashcat JWT.txt. This is where we save our JWT mode, which instructs hashcat on what to do, and then we have to provide the list of secret that it will try to brute force. And then we have to look for the status cracked and to see if a secret has been retrieved. Once you have the secret, go to JWT.io and you can forge your own token or impersonate another user to elevate your privileges. So it should look something like this, and this being the secret that has been extracted. So let's do this and see if we get anything out of it. I'm going to open this list, copy the link. So now we have actually let's not save it here. I saved it in the repo of JWT token. Let's save it here. And how does it look? This is our list. Let's change the name, something better, to JWT secrets word list txt, and then let's make a JWT.txt, and this is the file where we will store our own JWT token that we try to crack. So I'm going here and I'm going to copy our JWT. And it doesn't matter if it is expired or not. You can run this attack even on expired tokens, and if you have found the secret that was used to sign the token, then you can still forge a new token, and then when you forge it, you will set the expiration date to be a later one. I'm going to copy this and save it here, and let's see how it looks like. So we have our word list of secrets and we have our token, and now let's run hashcat, which is this one. So JWT, we have it, and here we put our own list and we run it. And I'm running it in a VM which doesn't have the proper resources to do it very fast, but the list is quite small, so it should be able to finish quite fast. Yeah, so it's done. This is the token. Let's see if it says, so we have the status cracked. Let's see what it says. So the status is cracked, which is great news. Check for status cracked, and we have to find the secret, which should be just after our token. Let's go back, and this seems to be the secret that has been used to create the JWT token and to sign it. So now that we have the secret that was used, we can go to JWT.io, use this secret to forge our own JWT. So now we have a token for Wally, and we will forge the token for admin, and then we will try to see if the application accepts our forged token. Let's copy this, and I'm going to JWT.io, which is over here. And where can we put the secret? The secret can be put here, and then we get a message saying that the secret is valid. So it is indeed the secret that has been used to create this JWT. So now we can forge our own JWT token, and to do that we have to go to, let me see where it was. JWT code, you have to press on JWT encoder. The UI is not very friendly. It's quite hard to miss, but these are actually buttons that you can navigate. So you have to be on the JWT encoder. You have to enter the secret, and then you will be able to get the signed JWT token with the values that you want. So now you can go in here and say admin, and I'm not sure if this is the right timestamp, if it's not expired already, but let's take it and check it in Burp to see if it's not expired. I'm going to send the tokens, paste this here, and we see expired, checked, failed. So we have to go back to JWT.io and put an expiration date. Is there a simpler way to change this? Because I don't know the expiration. What we can do is, let's say, epoch time. So we take the expiration from here, so put it here, we say timestamp to human value. So the expiration was today, day 12. What we can do is put 2026, let's say something like this, and we say human to timestamp, and we get another epoch time. So I'm going to copy this epoch time, go back here and set the expiration to this one. Now I'm going to copy the new token generated and check it if it's valid. I'm going to paste it here. Now we can see that the expiration, the check has passed, and that it expires in 2026, as we just said. So what I'm going to do now is copy this token that we just forged and try to access the home page using this token, which belongs to admin. And when I send the request, let's render the page, and we get a message, welcome admin, and the flag is this one. So we can see how, let's go back a bit and recap what we have tried. We went for attack vectors. The lab told us that what we have to do is to pivot and to move from the user Wally to the user admin. So because we knew what we have to do, we started by describing what kind of attacks and what kind of exploits would let us pivot from one user to another. So the ones that we mentioned to be out of scope was password spraying and password brute forcing, because we knew that the lab would not allow us to do this. So we marked this as out of scope, but then we found other ways that we could have done this, including broken access control, where we do file folder enumeration, and we didn't discover anything with this. Then we tried SQL injection, and our idea was try to either log in as another user or dump the database, find the hashes, and run a rainbow attack on the hashes to find the plain text password. We tried to do this with SQL map. We can see that in the SQL map tab, we filed the logout, the username, and the password, and we didn't find anything. Then we looked for leaked session tokens, for example, in the Wayback Machine, to see if there is any tokens that have been cached and that we can replay them. And the Wayback Machine, as we have already wrote, didn't return anything for this. Then we moved on to see, what was it, if we can find leaked tokens, for example, by triggering an error in the application. We tried that as well. And we tried by fuzzing the session token, the session cookie, and we tried by fuzzing, what was it? It was the username and the password. I think I didn't wrote here, but we tried to trigger an error in the application. When we saw that the application was handling pretty well the error and the invalid input, and it didn't give us anything back. So these three parts didn't work. And then we combined to some extent the weak session tokens and the JWT. We run JWT tool on our token. We saw, let's go back to Kali. We saw how to disable the proxy. We saw also how to set what's called a canary to instruct JWT tool on how to detect if the JWT is valid or not. Then we run some attacks, including the none algorithm, the spoofed, the injection, the RSA key. None of these worked, but then we got also some recommendations that we can also try the hashcat and the hashcat brute forcing cracking. And based on this and the lesson that we had on the SQRSEC tips and tricks, we tried to run hashcat on the JWT token, and we finally found the secret that it was used. So now that we got the flag, I think this pretty much is the whole lab. Thank you for your attention. I hope you learned something new, and I'll see you in the next vlog. Have a nice day. Bye bye.